All right, let's start. What you really need to know in this case is angle sum and difference identity, which is cos A plus B and sine A plus B. I will show you tangent A plus B, but it is actually an extension. It's not actually in the course, but I still prefer to show all of you that it's worth doing. Now, by the end of the lesson, you should be able to derive and algebraically prove the angle sum and difference identities for sine, cos. Not really in tangent, sine and cos. Tangent, I will not show you how to prove it. Right? Use the identity to simplify trigonometric expression, and then apply the angle sum and difference identities to determine the exact values of angles generated by 0, 30, 45, 60, and 90 degrees, and also of course in radians, and able to apply the identities to generalize other trigonometric results. Alright, now let's start off by looking at a unit circle. So if I've got 2 points on the unit circle, can you find an expression for the length of the chord PQ? Alright, so what you need to think about is, I want to look at this angle here. Right? This angle is actually A minus B. Correct? Yeah? And then the other situation is think about it, the chord PQ. I could use Pythagoras' theorem. 2 ways. So one, I can use this angle to find that length PQ, and also we can use Pythagoras' theorem. Now, starting off with Pythagoras' theorem PQ. PQ, knowing that the distance here is cos A minus cos B squared, sine A minus sine B squared, because it's the horizontal distance and vertical distance. And you can work out until you stop here. Alright? So expand it, cos A minus cos B squared, and so on and so forth. Now, then we can apply the cosine rule to triangle OPQ, which is OPQ. Knowing that this is A minus B, cosine rule. What is cos A minus B? Alright, now can you actually notice when you do that, what happened to this equation and this equation? This is equivalent to that, correct? Yeah? Agree? So I'll leave it up to you to actually expand that. But let's concentrate on these two. PQ equals to that, PQ equals this. Alright, let me highlight these two. What is it telling me? They are equal, correct?
Yeah.
For this to be the same as that, you've got the 2 as a constant, you've got 2 as a coefficient. Therefore, if this is x, this must be x as well.
Yeah.
So now, let's come to the angle difference. Cos A minus B is therefore cos A cos B plus sine A sine B. Alright, this is the first one. This is one that you need to know. Cos A minus B equals to cos A cos B plus sine A sine B. This is how you derive it. Now, then, based on that, we can try to derive cos A plus B, sine A plus B, or sine A minus B. So, alright, so that is an angle sum and difference. Alright, let's go to the next bit. Now we could use the established identity, this one. How do we establish an identity for cos A plus B? Alright? Now, let's think about it. Cos A plus B, cos A minus B. What is cos B? What does cos B equivalent to? Cos minus B, right? So if you think about that, cos B is the same as cos minus B. So we can substitute minus B as plus B, because cos minus B equals to cos B. Correct? Yeah? So now, therefore, we've got cos A minus B would therefore be equals to cos A, let me write that properly, cos minus B plus sine A sine minus B. Alright? Now, again, because we know that this is plus, and that will be minus sine B. Sine minus B is minus sine B. Correct? So therefore, we've got cos A cos B minus sine A sine B. Alright? So therefore, we can write down the next identity, cos A plus B equals to cos A cos B minus sine A sine B. Alright? So now, using what you have learned, because we know cos minus B is cos B. Alright? Think about your unit circle, CAST. So, cos B, if you're not sure, have a look. So if I've got my unit circle here, if this is cos B, and this is angle minus B, cos B is the same as cos minus B. Yeah? So you can substitute in there. Now, then can we prove that cos 90 degrees minus theta equals to sine theta? How do you do that? So we use and substitute into one of that. So this time we know that cos 90 degrees minus theta equals to cos 90 degrees cos theta plus sine 90 degrees sine theta. Correct? So what is cos 90? Cos 90 degree is 0. Cos 90 is 0. Therefore there's 0. Sine 90 is 1. Sine is y coordinate. Therefore, think about it, 90 degrees is at y axis. So y equals to 1. Sine theta. Therefore, cos 90 degrees minus theta equals to sine theta. Right? So if you get confused, what you want to think about is the unit circle. X is cos, y is sine. Alright? Think about the four points. Think 0 degrees, 90 degrees, 180 degrees and 270. Or 0 minus 90, minus 180 and minus whatever. 270. Alright? So next. Now, here, can we establish an identity for sine A minus B then? Alright? We need to be able to identify that. So, sine A minus B. How do we do that? We know that this equals to cos 90 degrees minus A plus B. And therefore equals to cos 90 degrees minus A minus B. Alright, now let's combine these together. Alright, let's combine these together. That is cos. So using the cos A minus B, the identity of that, cos 90 degrees minus A cos B plus cos 90 degrees minus A sine, sorry, sine 90 degrees minus A sine B. Alright, so therefore, what is cos 90 degrees minus A? It's actually sine A. So it's sine A cos B plus cos A sine B. Correct? because sine 90 degrees minus A is actually cos A. So writing it out again, sine A minus B equals to sine A cos B plus cos A sine B. Now I'm going to show you all the proof, but I haven't really seen a lot of exam questions or test questions on the proof. So I'm going through step by step, just showing you what it is like. All right, understand, you could prove it.
So,
Yeah.
isn't it must be cos minus B?
Sorry? Yeah, cos minus B is the same as cos B. Isn't that right? Sine minus B, that would be, my fault. That would be minus. Yes, you're right. That's minus, not plus. Minus, 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 minus. Yes, thank you. Minus sine B. Yep. Oh. Oh, that's plus. That's minus. Yep. All right. Now, therefore, we can establish an identity for step. Sine A plus B. Sine A plus B. All right. Actually, we know that we're going to start off slightly different. Sine cos 90 degrees minus theta is actually equals to cos 90 degrees cos theta plus sine 90 degrees sine theta. Oh, hang on, what have I done? Wrong one. Wrong. I'm looking at my own incorrect notes. All right. Let's do this again. Again, let's substitute minus b as plus b. So we now have sine A minus b. All right, because this is minus will give you plus. A plus b is A minus b, correct? If I substitute b as minus b as plus b. So therefore, we now have equals to sine A cos minus b minus cos A sine minus b. All right. Since cos minus b is the same as cos b, we therefore have sine A cos b minus sine minus b is minus sine b. Therefore, minus is plus cos A sine b. All right. So therefore, sine A plus b, rewriting it equals to sine A cos b plus cos A sine b. All right. This is how you use all the information you have, what you have learned, to actually work that out. All right, this is thinking about how to derive the angle sum and angle difference. Now, what I want to show you is why, hang on, this is a summary. The summary of this is what you really need to know, and it's actually in the formula sheet. All right, the formula sheet will give you all this, but it will be written in such a way as cos A minus or plus b equals to cos A cos b plus or minus sine A sine b. And then this one will be sine A plus or minus b equals to sine A cos b plus or minus cos A sine b. Alright? This will be given in such a way. They are the same. Remember, cos, if it is minus, this will be plus. Plus will be minus. Whereas it's plus, minus and minus. Alright, next. What I'm going to show you is why is cos A plus B is not the same as cos A plus cos B. Oops. All right, let me use my ruler. I need to draw something out to show you. So if I've got cos A, let's do this. Let's say this is A. This is A. And this is B. All right? Now, what is A plus B? A plus B is something like this. Let's say this is A plus B. All right? This angle here is A plus B. Now, what happened in this case is this would be cos A, the coordinate, and this is sine A. The coordinate here will be cos B sine B. And the coordinate here will be cos A plus B sine A plus B. Alright, if you think about cos A plus cos B, that will be this distance. Alright, this distance plus that distance. Correct? Yeah? So if cos A plus cos B is that and that, it is actually not the same as this distance here. Right? So therefore cos A plus cos B is not cos A plus B. Got it? Prove it in a unit circle. You've got a unit circle. This is angle A, this is angle B. You know that the x coordinate is cos A is cos A, x coordinate of B is cos B. Alright? So cos A plus cos B, it will extend all the way up there. The distance is this plus that. Alright? Whereas, think about that. The distance is only there. So you cannot actually add them together. Happy with that?
Yeah.
Yeah? Okay, good. Let's go on. Now, can you actually start thinking about how we could use those identities to determine something like cos 105? Alright. What would cos 105 made out of?
60 plus 45.
45 plus 65. So cos 105 degrees equals to cos 45 plus 60 degrees.
Yeah, 60.
Alright? So now you can start using the angles sum. So that will be cos 45 degrees, cos 60 degrees, minus sine.
So it's sine.
Sorry?
Sine.
Oh, it's sine, not cos. My fault. Thank you. It's the same principle if you use cos. So this is sine, sine. So it's sine 45 degrees, cos 60 degrees, plus cos 45 degrees, sine 60 degrees. Alright, so use your knowledge. So that will be 1 over root 2. Use your knowledge of the unit circle, or knowing what the exact value of these are. Cos 60 is 1 on 2, plus cos 45 is 1 over root 2. Sine 60 is root 3 over 2. Is therefore 2 root 2 over 1 plus root 3 over 2 root 2 equals 1 plus root 3, 2 root 2, which is root 2, 1 plus root 3 over 4. Alright? You must be able to work out, rationalize your denominator. Alright, next one. Let's try cos 165 degrees. How would you do that? Alright, let's think about the unit circle. So think about the unit circle. if you've got,
Cos 120, which is the same as
all right, now
90.
cos minus 100, cos 165. 165 degrees is somewhere here. Correct? 165 degrees. Now, what is the reference angle that you need? What is the reference angle? It's 165, not 160. Hey? 15 degrees. So,
60 take 45.
all right? It is 60 take 45. However, you must recognize that because this is CASD, what would it would be similar to negative cos 15 degrees. Correct? Think about that. This is CASD. C is cos positive, all positive, S sine positive, and tan positive. So now you can work it out. This will be minus cos 45 degrees minus 30 degrees. All right? Work that out. Minus cos 45 degrees cos 30 degrees plus sine 45 degrees sine 30 degrees, which is minus cos 45 is 1 over root 2, cos 30 is root 3 over 2, plus sine 45 is 1 over root 2, sine 30 degrees is half, equals to minus root 3 over 2 root 2, plus 1 over 2 root 2, equals to 4 minus root 3 minus 1. All right? Oh, sorry, I need the square root of 2. Oops, my fault. Minus square root of 2. All right, root 3 plus 1. So think about how you could solve it. Use your unit circle and use your knowledge of 45 degrees, 30 degrees, 60 degrees, and so on and so forth. 4 more examples, and then I will finish off there. Now, what about this? Can you express the following trig function in terms of sine and cos? So you've got sine and you've got cos. So I want it to be in terms of sine and cos, so therefore you need to use your trig function. So this angle sum and angle difference. So therefore this is 9 into sine x cos pi over 4 minus cos x sine pi over 4. That will be equal to 9. Now, cos pi over 4 is 1 over root 2. Sine x minus sine pi over 4 is 1 over root 2 as well. Cos x. Therefore, it's 9 over root 2 sine x minus cos x. Or if you like, you can do 9 square root of 2 over 2 sine x minus cos x. Alright? Would you try this one, please, before I show you my solution? Try the second example, please, using your angle sum and difference. Right, try this, please. All right, use your angle sum identity. So it's cos x plus cos 2 pi over 3 minus sine x sine 2 pi over 3. And of course, you know the exact value of cos 2 pi over 3 and sine 2 pi over 3. And then it should work out to be cos 2 pi over 3 is minus half because it's in the second quadrant. Sine is positive, second quadrant. So therefore, you can work it out. 5 over 2 cos x plus root 3 sine x. All right. Now, the next question is pretty much, I've seen quite a lot of exam questions like this, or test questions. Generally, you will not even be told to draw two right angle triangles. You're just given this and asked you to derive that. If you have a question like this, what you need to do is draw two right angle triangles without prompting. So if this is x, is 8 over 17. All right? Y is 3 over 4. So therefore, this is 5. Now, this is where, if you know your Pythagorean triple is pretty straightforward. You would know that 8 and this will be 15. So therefore, you can use cos x minus y equals to cos x cos y plus sine x sine y, which means cos x cos y is plus sine x sine y, 3 over 5. So that would give you 84 over 85, if my maths is correct. All right? Link one question to the other if we are given the ratio. Always draw two right angle triangles. You got to be also careful sometimes if you have a question like this. If you are given sine and cos, and if you have asked to find tan, please draw out the triangle again. All right, make sure that you always draw the triangle to make sure that you got the right triangle. All right, now sometimes we will think about how we could do a reverse angle sum and difference to solve problems like this. All right, so to solve problems like this, for example, half cos x minus square root of 3 over 2 sine x equals to minus 1. Here, would you use what is half? Sine 30 or cos 60? All right, same here. What I would do is when I solve it, I'll change that to sine 30 degrees cos x minus cos 30 degrees sine x equals to minus 1. Of course, you can have this as cos 60 degrees and sine 60 degrees. That's fine. It's either way, you will get the same answer as well. So from there, you can work it out as sorry, that's sine and cos. Yep, equals to minus 1. So therefore, cos 30 degrees sine x minus sine 30 degrees cos x equals to 1. Alright, multiply both sides by 1. Alright. So therefore we know that cos sine x minus 30 degrees equals to 1. Alright, remember, changing your domain, that will be minus 30 degrees, x minus 30 degrees, and 330 degrees. So you know sine x equals to 1, CAST, and this point over there. So x minus 30 degrees equals to 90 degrees, x therefore equals 120 degrees. Alright, there will be no other solution except that one because sine x is 1.
Wouldn't it be 60 degrees?
90 plus 130 plus 30 is 120, not 60. Alright, finally, I'm just going to give you tangent A plus or minus B is that. It's actually an extension, so I will show you what to do, but I don't think you actually need to know that in the exam. Alright? So if you look at this, we can use tan 105 degrees equals to tan 60 degrees plus 45 degrees. Alright? So here, tan A plus tan B. Tan 60 degrees plus tan 45 degrees over 1 minus tan 60 degrees tan 45 degrees. Alright, tangent of 60 degrees is root 3 and tan 45 is 1. 1 minus root 3 times 1. So equals to root 3 plus 1 over 1 minus root 3. Now this time I want to rationalize it. Multiply both sides by 1 plus root 3. 1 plus root 3 to rationalize that. So therefore, that is 1 minus 3. 1 minus 3, square root of 3 plus 1. 1 plus square root of 3. So therefore, expand everything out, you should have 4 plus 2 square root of 2 over minus 2, which is minus 2 minus root 3. Alright? So this is how you could use your tangent angle sum identity. Alright, this is just a summary. You will be given those in the exam or test in the formula sheet, so you don't have to worry too much about that. Alright, I'm going to stop here. Don't do any exercise on this until after the test, which is Wednesday. Not included in the test.